All right, cool. So hopefully that's going to be something we can see. Let me start off with something really basic problems. So that's why I want you to put your calculators away. Just try to do these honestly. Those three for right now. You see that? Kind of a long room. Kind of sucks. Oh.
How would you like me to do this?
No, sure. This is part of what I needed to ask you. How have you done that in the past?
I told people how to write it. They did it the way I told them to, and I did the poem.
Oh, I see. Okay. But of course, I don't think they're able to use somebody to come into class with that.
No, but I can try to do that. Or you can request it from the SPS.
Oh, cool.
I don't know how that works, but
I'm not sure either. But I think you and I need to go see the SPS. When we're doing group work and things like that, I'm not sure how it should be structured. Because I can't necessarily stay here because I might have to go around the class. So I need to figure out if we get somebody to spend the class. I don't know where the kids is first from.
I don't know either.
All right. So for today, just hang out, and then we got to figure out. Let me email them and see if there's a certain way that they want to, if they can have somebody come in or something.
Okay.
Okay. Yeah. This room is not. I know it's the homework will be. So one part of this is just knowing, for example, what this means. Is it really cool what this means? What does that tell you? Multiplication, cool. Okay. As I erase it. Does everyone know how to do this from? All right. So what do you guys get for that first problem? It used to be 7 times 8. I don't know. 56, cool. So that, of course, I really, on test 1 especially, but on a lot of the tests, there's going to be components where I have like a part 1 and a part 2. Part 1, you cannot use a calculator. Part 2, you can. Even when you can use a calculator, you still have to show work. I'm just letting you kind of check it then. Here, if I'm asking you to do this by hand, I really don't want to see like 7 8s and you're adding them together. You know, it's good to understand that that's what that means. But that's not the intent. 7 times 8 should itself be a very basic thing that we know to build on. I shouldn't have to kind of tear that one down itself. It should just be, we should know 7 times 8 is 56. All right. How do I do this one then? That one, I don't know my 119 times tables. Right? So this one, of course, you got to tear that down a little bit. But what do you get here? Yeah, good. So you get 6 and you carry 3. 4 times 1, 4 plus 3, 7.
4.
Good. And of course, what do you put in here?
0.
0 or just a space, however you want to do it. Because really, the reason you put that there is this is not 4, this is actually 40. Right? It's 44. So that 0 at the end is going to have a 0. It's like multiplying by 10. You're going to have a 0 at the end. So now 4 times 9, you kind of repeat everything again, right? Yeah, 6. 3 is still there again. 7. 4. Good. And now you just have to add those together. So one main thing I wanted to see there is if you remembered, you have to give some space here. Some people kind of forget that idea. It's good to know why that is, and that's really why it is. This is 4t. So there's a 10 in it. So it's going to be 10 times as big on this one, so it's always going to have a 0 there. And then when you add these together,
6, 3, 2,
I
5.
like it. Cool. Right. And then number 3. Now, tell you honestly, how do we set this up in the States and in a few other countries? How do we set this up?
Put the
Kinda-
7 on the outside.
Yeah, put 7 here.
147.
347 there. Anybody brought up with a different way to do it? Anybody? Because very often, for example, I always remember the Russian student I had, and to tell you honestly, I haven't seen it in a long time, so I can't even try to remember, but it's not the same way.
You do it backwards, it's upside down.
Yeah, and they kind of put things in different places. So there's a thing you learn in Math 110 that involves variables in division. Oh, yeah. So when they get there, they're really screwed because they're being taught how to do that weird thing in this format that they're not used to. Just wanted to see if everybody can do it this way here, right? You kind of want to get this down so you're ready for that Math 103, 110 thing. So now, what do I do with this 7 here?
Find the 34.
Good.
4.
4.
Good. And you put the 4 over the last digit. Don't put it here because that'll be a little misleading for decimals. You'll think it's bigger than it really is. So 4 times 7?
28.
28. Subtract that bad boy. Good. 6.
Maybe drop the 7.
Drop the 7.
9.
Good. 9? Yeah, 9 times 7? 63.
4.
Now, there's 2 ways. One way that we start with is to do the big R. Right.
Remainder.
But the other way that, if you want to do this, I have absolutely no problem with it whatsoever, is how should you kind of write this 49 and
Over.
4
7.
sevens? Love it.
Can you put after the 9 point and put point and down?
Oh, sure. The third way to do it is to kind of put the point and add zeros and go into decimals. I'm going to hold off on decimals. There's a whole section devoted to decimals. So right now, the 2 ways I'd want to see this answer is as a big R remainder, because that's the way the book kind of does it for right now, or as a fraction. What do you actually call this kind of thing? It's got a whole piece and it's got mixed number. I like it. It's called a mixed number because it's mixed. It's got a whole number and it's got a fraction. It's a mix of types. How would I change this into? I know I'm getting a little bit ahead of myself. If you don't remember, don't freak. How do you change it into an improper fraction?
Multiply 49 7 that.
I love it. So do 7 times 49, and then add 4. And of course, you already know what that would be. 360. That's exactly how it started off, right? You guys with me? Okay. Now watch this real quick. I want to show you this. Anytime you get a remainder, and here's something kind of cool. If it's remainder 4, can anybody tell me what number does that kind of tell me that 7 would go into directly? It would have no remainder then. What does that 4 really mean? This is 4 too big. So if it would have been 343, 7 would have went into that exactly 49 times. There would have been no remainder. So when you see a remainder of 1, that means that number was 1 too big. There was 1 too many. So really, here's something kind of cool. And again, I tend to do this. I'll throw a lot at you. And it might be ahead of where we are officially, but it's all stuff related to what we're doing. So I want you to be more comfortable with more advanced stuff. It's all related. If I take this and I write it like this, no, Jeff, you're thinking ahead. Okay. Is that, am I allowed to do that? Yeah, you're the teacher. No. 347 is 343 plus 4, right? It's the same thing. No. Yeah, these are the same thing, right? This is just, it's sort of like if I had 4 over 5, I can write that as 3 plus 1 over 5. I mean, there's sort of like, well, yeah, 4 is 3 plus 1. Yeah. But 7 goes into this exactly 49 times. Does 7 go into 4?
No.
So that's left over. So that's sort of another place where that comes from. A. So that's why I'm allowed to put that over that. I mean, don't just accept it, you know, that I'm the teacher, I'm telling you, you can put 4 over 7, just accept, no. That's why I can put 4 over 7, because that's a whole other way I could have done the problem. Maybe. Real quick, while we're talking about division, what number can you not divide by?
Zero.
Why?
Value the zero value.
Well, what is it really? In fact, what do you normally call it? When you,
Zero is just a placeholder, isn't it?
not really. It's a valid thing in itself. But I mean, like in this number here, it's kind of pushing the 1 into the hundreds place. But they're still telling you have no 10s, no 1s. They're still, by themselves, they're still valid. But I understand what you mean when you say that. But here's the neat thing, watch. Now this first question is going to be kind of silly. Why is that true? Don't say because 2 goes into 6 3 times. That's what that says. 6 divided by 2 is 3 because 2 times 3 is 6. So 6 divided by 0 must be the number that when I multiply it by 0, I get 6. Is there any number defined to do that?
Zero?
No. 0 times 0 is 0. So the answer, if there is an answer, it must be the number that when I multiply it by 0, I get 6. Because, why is this 3? Because when I multiply it by 2, I get 6. You with me? So this number has to be the number that when I multiply it by 0, I get 6. Is there any number that does that?
No.
Yes, good. I mean, no is right. No is the right answer. There's no number defined to do that. So very often what you'll call this is undefined. I don't know if anybody's ever seen that before, but that's why we call it undefined, because there's no number defined to do what that says it should do. Again, don't accept something, a terminology, a definition, a process. Don't just say, well, they told me that's the way it is. Because that's going to feed into your whole brain going, math is for crazy people, I don't know, and I'm just going to try to figure out what the hell the steps are, and screw it. You should be able to understand why the hell we do what we do. It makes sense. And the more you go into that, the more sense any math is going to make. Okay, hold on. Okay. So how's that so far, you guys? All right? I don't want you to freak out about, I am occasionally getting a little further than we really are officially, so if any of this is kind of like, I'm not really sure what the hell just happened, you're okay. All right, it's not going to go that quick as you're doing your homework. Let me ask you this here. Take a second and try to write that number down in words. Oh, crap.